fact, the farmer. I'll come back to that. In the next picture, I'd like to show you a horse-driven chariot, and you might like to guess the name of the company who actually built that. You do know it, but I will show you the information right here. And it was actually built by the Buick Company. Buick Company, before the introduction of the internal combustion engines, was in this business. Similarly, this is the International Grain Tank, and the explanation here will show you that this was built by International Harvester Company. So the business changed from here to the big trucks and that we know the truck that this company is building for their farming companies. Now, as the tractor started, Canadian horse-based agriculture was replaced by tractor agriculture, and farmers, the people, needed less knowledge about horses, but more on machine skill and lubrication. I think that's exactly the pattern that's coming with the computers. So, better farmers were able to adapt themselves to the new requirement, and they were involved in motorized farming and increase their efficiency and the size of the farms. Now, I will also make a remark on the camera. The camera was essentially invented in 1856, I think, and changed a lot. We don't really know much about it, but I was in a lecture in Chicago about 10 years ago, and I learned there that, in fact, the camera is responsible for some of the changes in painting. And, of course, the camera right now is helping us with the movies and as an industry, but also in education as well. Now, this is the way in 1836 Istanbul was pictured by a painter. And when you look at the Gauguin and Van Gogh communication, 1886, what Gauguin said, we do not have to copy nature, we should paint our imaginations, our dreams and perceptions. And then that's the type of paintings they started painting. Now, the next one will show something that you may know already. And this is Gauguin, Van Gogh's bedroom. This is Van Gogh painting in southern France. And probably you might know this very nice. So we did not know that, in fact, the change in mind came from the camera. So the key thing I find is that they did not imitate their masters. They decided to do their own things. And we can look at the computers, and computers also changed a lot of things. Started new industries like Microsoft, in particular engineering and education changed. And my concern is, as an educator, what's the impact of the computers in engineering practice and engineering education? Or put it the other way around, am I competing with computers in contrast to the way Gauguin tried to avoid competing with cameras? Now, the next thing is, how do we change? What takes to change? To change, first, we have to change ourselves, our minds, and that's not an easy thing to do. But some universities took the challenge, and I was at the University of Michigan about 10 years ago, and I observed that they built a completely new campus, North Campus, mainly for high tech. And they installed a computer-assisted engineering network. This is an incredible task. And each student is able to access any type of software that he needs to. And modernize the engineering curriculum, and they publish their experiences. Now, this is the library, but the name is Media Union because you don't see lots of books, but essentially you see computers inside. And the key thing is, I like this, my friend David Maher told me that he sees computers as microscopes, and he says they give us new dimensions. That's the thing that's kind of important to visualize. So in engineering, the computers changed engineering, and the engineers of my generation were able to specialize in one area. Yes, they were very successful. They went to the moon, but that doesn't seem to be sufficient right now. Now, if you look back, the equations and methodology did not really change. I learned this from a friend that in 1930s in Germany, in the airplane company Messerschmitt, they had a collection of ladies, 6 ladies. They were able to invert a 6x6 matrix in a day. So you provided the 6x6 matrix in the morning and got the inverse in the afternoon. But right now, of course, that's not a big deal for any engineer. But tools change. The tools change: drawing equipment and 3D representation, rendering, quick prototyping, and essentially numerical rather than analytical or digital that we have seen. This was referred to in the previous lecture given to us on maneuvering. Now, another change came in education. Books, recorded material changed, classrooms changed, teacher-based, student-based, project-based, and case-based studies became very relevant, and distance education is, of course, part of us. Now, I'd like you to tell you that in the Roman times, in Bergamo, Turkey, there was a big library, and the historians tell us that about 5,000 scribes copied books for various libraries around the world during the Roman times. Now, in contrast to that, now you can find free books available from MIT Books. So if you go to the your computer and go to MIT eBooks, you may find the book that you are really interested in. Now, for new knowledge, in the past, you had to travel. Now, Pythagoras went to Baghdad to learn how to calculate the square root of integers. And his theorem, so a squared equals b squared plus c squared, he had to travel from Greece to Baghdad, and then he learned his theorem, and he brought that to Greece. But now you don't have to travel. You just have to go on the internet, send email, and use e-books and e-colleges and so forth. All right, I explained that earlier, but I'd like you to connect us to the gap. Everything that I will say is really to reduce that gap. Now, my assumption, this is an assumption that's maybe not relevant to all countries. My assumption is that the United States and Canada, this gap is a result of the changing expectations and practices in engineering in the workplace. And that change is really a result of the application of the computers to the workplace. So I see the gap very similar to the gap farmers experience with the internal combustion engines and the painters experience with the camera. Computers took the load of analysis and hand calculations of the practicing engineers, and engineer then was expected to optimize things, work with a team, and study required to be very competitive. Now, as a good example, we can possibly see that the big competition that resulted from the existence of the Airbus company and Boeing. Now, so I look back and then I'll try to document for you what happened in the education. And of course, fluidity is the important thing. Fluidity is the ability of society or the person to change in time. And this is the example of a teacher-based instruction, which is really good for a large classroom. And the next one will value that some educational material for all students. So teacher-based education is not bad. It provides the material for all students. And there is an agreed-upon curriculum. It's cheaper, large classes, more accountable, and unfortunately, the measurement of the student is based on short answer questions, and it provides standardized tests